Today we're going forward with more of section R5 and equations. So looking at absolute value equations. In order to solve absolute value equations, we need to know that if the absolute value of a number, such as u, is equal to a number, such as k, then u could be k or negative k. Okay, so we're going to set up for possibly two solutions to these equations. If the absolute value of u is 0, then u is 0. Pretty simple. If the absolute value of u is a negative number, then there's no solution because you can't have the absolute value of a negative number. If we were plugging negative k for u, it wouldn't work. So we can't have that. And then what if we had the absolute value equals absolute value? Well, in that case, the absolute value of u could be positive w or negative w, again, just as in rule number 1. So, looking at some examples, the first one we want to do is get the absolute value on one side by itself. So we need to get rid of the 2. So we're going to divide both sides by 2. And when we do that, then we have the absolute value of 3 minus 2x is equal to 3. Now we can set this up with our absolute value rule. So 3 minus 2x would be positive 3, or 3 minus 2x could be negative 3. And we solve each of these equations for x. So subtract 3 from both sides on the left one, and we get 0. Divide by negative 2, and x is 0 here. Solving the next one, subtract 3 from both sides again. We got negative 6, and divide both sides by negative 2, and so x is 3. Now let's just look back up and make sure both of these would work. We could write this out, but I think we can do it in our head. So 0, if we plug that in for x, then we'd end up with 2 times the absolute value of 3. Absolute value of 3 is 3, and 2 times 3 is 6, so that's good. If we plug in 3 for x, then we have 3 minus 6, which would give us negative 3. The absolute value of negative 3 is 3. 2 times 3 is 6. So both of these values would be solutions. So our solution set is 0, 3. Another example, again, get the absolute value on one side by itself. So I'm going to put, just because I like things I'm solving for to be on the left over here, and then we're subtracting 8 from both sides. So if we do that, we've got 2 minus 8, which is negative 6. Excuse me. Now we talked about this. We cannot have an absolute value giving us a negative. So the fact is that there is no solution for this equation, and we write our solution set as braces with nothing in the middle. For example 2, our rules say that we're going to put 2x minus 5 equals positive x plus 1, or 2x minus 5 equals negative x plus 1. Notice how I've put it in parentheses because we have to make both the x and the 1 negative. And so we're going to solve each of these. So I'm going to subtract x from both sides. That gives us x minus 5 equals 1. And then add 5 to both sides. So one of our solutions should be 6. With the equation on the right, we need to distribute the negative. And then I'm going to add x to both sides. Add 5 to both sides. It gives us a positive 4. And then divide both sides by 3 so that x is 4/3. And we could write that as 1 1/3 or 1.33, depending on what your answer is asked to be written as. Okay? Both of these do work in this situation, so our solution set is 4/3 6. Same deal here. We have 6 minus x equals positive x minus 6, or 6 minus x equals negative x minus 6. Okay, and so we solve both of these. For the one on the left, I'm going to add x to both sides. Excuse me, subtract x from both sides. So we have 6 minus 2x equals negative 6. Subtract 6 from both sides. We're trying to get that x by itself. So we got negative 12 over there. And divide by negative 2. So x is 6. For the right-hand equation, distribute the negative. Add x to both sides. When we do that, let me write this one out so you can see. You can see that it cancels out both our x's. And we end up with 6 equals 6. Now remember back, if we have two things, if our x's go away but we have a true situation, then our answer is all real numbers. If it wasn't true, if it was false, then there would be no solution. Now, why don't we write this as that? Well, we don't, because all real numbers would include 6, wouldn't it? So we don't need to put that in there. We don't need to put the 6 in there. Solving radical equations. We've already talked about the radical rules. I'm going to get the radical on one side. So we've got the square root of x plus 10. Add 4 to both sides, and we've got x plus 4. To get rid of the radical here, the easiest way to do that is to square both sides. So in that case, we just end up with x plus 10 on the left, and we're squaring x plus 4. So that gives us x plus 4 times x plus 4, which we're going to have to FOIL. So x times x is x squared. Then we have 4 times x plus 4 times x. Well, that's 8x. And then 4 times 4 is 16. So we've got a quadratic. In the case of a quadratic, we need to be set equal to 0. And as usual, I like to have what I'm solving for on the left. So we're going to subtract x from both sides. And at the same time, I'm going to go ahead and subtract 10. So we'll write that out. Okay, and that'll get rid of everything on the right there. So we have x squared, I'll go up here, plus 7x plus 6 equals 0. And now we need to solve for x. In this case, it will factor. What will multiply to give us 6? That will add to give us 7. Well, 6 and 1. So we set both of those equal to 0. So x could be negative 6, or x could be negative 1. Now, as I've said before, with radicals, we need to consider, are both these values going to work? So we do need to check it. So our original equation was x plus 10, square root of that, minus 4 equals x. Okay, so let's try negative 1. So we'd have negative 1 plus 10, the square root of that, minus 4 equals negative 1. So negative 1 plus 10 is 9. The square root of 9 is 3. And does 3 minus 4 equal negative 1? Yes. So negative 1 will be in our solution set. And then we need to try negative 6. Negative 6 plus 10 is 4. The square root of 4 is 2. Two minus 4 is negative 2, which is not equal to negative 6. So 6 will not be in our solution set. Our answer, our only solution, is just negative 1. Let's look at another radical. So for this one, again, best way to solve these is to square everything. Let's see. If we get a radical on each side, that's going to make things easier for us. So I'm going to add the square root of 3x plus 1 to both sides. And that gives us this here. And now we're going to square both sides. So on the left we get x minus 1. Right is more complicated because here we've got a binomial that has to be squared. We're going to have to fool with all this mess. Okay, so here we go. If we take the square root of 3x plus 1 and multiply it by itself, we get 3x minus 1. Okay, easy enough. Then we have square root of 3x minus 1 times negative 2. That's negative 2 times the square root of 3x plus 1. Then we do that again for the inside. So that gives us negative 4, when we add them, times the square root of 3x plus 1. And the negative 2 times negative 2 is 4. So we've still got a square root in here that we need to get by itself. Let's simplify both sides first. So we've got 3x. We can't take negative 1 minus 4 because the 4 is attached to the square root. But we have negative 1 plus 4 over there on the end, and that's going to give us a 3. So we got 3x minus 4 square root of 3x plus 1 plus 3. Okay, need to get the square root on one side. So let's subtract 3x from both sides. And subtract 3 from both sides. I have to take that to the next page. Okay, so we've got this. And so now we've got negative 2x minus 4 equals negative 4 times the square root of 3x plus 1. Okay, something that would be nice, since everything there is divisible by 2, and it's nice to get rid of negatives, then we're going to divide everything here by negative 2. just to clean things up. So we have x plus 2 equals 2 times 3x plus 1. And I think I've made a mistake in here somewhere. Let's see. Oh, crap. Back here, this was supposed to be a plus. Oh my goodness, I'm so sorry. Okay, that's going to change things a bit, so let's go back and do some erasing. I hope you're using a pencil. Important to use pencils with math because even the teacher makes mistakes. Okay, so that's going to give us instead a 5 over here. And then we would subtract 5 from both sides. So that has us as, let's just start back from there. Okay, so in that case we've got negative 2x minus 6 equals negative 4 times 3x plus 1. And now we're going to do that same deal where we're going to divide everything on both sides by negative 2. So we have x plus 3 equals 2 times 3x plus 1. Okay, good. Now we're set. Okay, still got to get rid of the squared. So, or the square root. So we're going to square both sides again. So we've got x plus 3 times x plus 3. For that, we've got x squared plus 6x plus 9. If you need to go to the side and work that out to see where I got it, that's fine. Then square the 4, or square the 2, that gives us 4, and square your 3x plus 1, or square root of 3x plus 1, and we just have 3x plus 1. So we now finally have gotten rid of our square roots. Distribute the 4. And then we need to get everything, since we've got a square, everything on one side set equal to 0. So let's subtract 12x from both sides and subtract 4 from both sides. So when we do that, we've got x squared minus 6x this was supposed to be a plus, so plus 5 equals 0. And now we can finally factor. So that'll be x minus 5 times x minus 1. Set them both equal to 0. So x is 5 and x is 1. Yes, you should go through and check those. So if we go back to our original equation, on the left here, 1 minus 1 is 1, the square root of, or 1 minus 1 is 0. Square root of 0 is just 0. Then we've got 3 times 1, that's 3, plus 1 is 4. The square root of 4 is 2, so that gives us negative 2 equals negative 2. Okay, so we're set with 1. With the 3, we've got 3 minus 1, that's 2. Or no, excuse me, 5. 5 minus 1 is 4. Square root of 4 is 2. Then we have 3 times 5 is 15, plus 1, that's 16. Square root of 16 is 4. Does that equal negative 2? Yes. Okay, so both of those numbers will be in our solution set, 1 and 5. Okay, just a few more here. What if we have a rational power? Well, this is the same thing as a root of sorts, so we know that x plus 1 to the 2/3, because we've already looked at rational expressions, is the same thing as the third root, because what's on the bottom goes into the root, of x plus 1 squared. Okay? We need to get rid of the 2, so divide both sides by 2. This equation is not as hard as you would think it is, luckily. To get rid of a third root, we raise everything to the third power. So we end up with what's on the inside, x plus 1 squared equals, and 4 cubed is 64. How do we get rid of a squared? We take the square root. So square root of both sides gives us x plus 1 equals plus or minus the square root of 64, which is 8. So we have two possible solutions here. We have, if we add 1 to both sides, we've got x equals plus or minus 8 minus 1. So we've got x equals 8 minus 1, or x equals negative 8 minus 1. So that's 7 and negative 9. Okay, we do need to check these because of the root situation. Okay, so with the first one, I'm going to go ahead, I'm going to use this equation here because that's easier for us to look at. So plugging in the 7, we have 2 cubed root of 7 plus 1 squared equals 8. 7 plus 1 is 8. 8 squared is 64. The cubed root of 64 is 4. And 2 times 4 does equal 8. And then we need to try negative 9. Okay, don't let the negative square scare you, because we are going to square it in there. So we've got negative 9 plus 1, that's negative 8. Negative 8 squared is 64. So we get the same situation. 2 times 4 is 8. It works. And so our solution set includes both 7 and negative 9. Let's work one more of those with a rational exponent there, just to make sure we got it. So here, let's go ahead and that'll be a fourth root of x minus 4 cubed. Divide both sides by 54. Excuse me, divide both sides by 2. 27. Okay. In this case, we can't take, well, we could go ahead and raise everything to the fourth power. That would be 27 to the fourth power. That would be astronomical. What if, remember, we could rewrite this like this. That's actually going to make our work a little bit simpler because we can cubed root both sides to get rid of that cube there. And so that we have the fourth root of x minus 1 equals cube root of 27 is 3. Now to get rid of the fourth root, we can raise both sides to 4, and that gives us a little bit more easy to use numbers. So we have x minus 4 left equals 3 to the fourth power is 81. So add 4 to both sides, and x is 85. If we check that, yes, it does work. Well, let's go ahead and check it. Write it out here. So we've got 2 fourth root of 85 minus 4 cubed. Be easier to look at it this way. Okay, so 85 minus 4 is 81. And the fourth root of 81 is 3. Three cubed is 27, and 2 times 27 does give us 54. So our solution set is just 85. Okay. 2 more examples. So here's your problems where you're solving for a variable and you've got other variables in there. Don't let it scare you. It's just the same as any other problem. We just have to carry around variables instead of getting rid of stuff with numbers. But let's start by getting rid of that fraction. We don't like fractions, right? If at all possible. So we're going to multiply both sides by 3. So that we have 3v equals pi r squared h. And we're solving for r. So both the pi and the h are being multiplied by r squared. So we're going to divide both sides by pi h. So that gives us r squared equals 3v divided by pi h. We're not changing pi to 3.14 and dividing into 3 there and getting a decimal and all that mess because we want an exact answer. Okay? And so to get rid of a square, we take the square root of both sides. So that gives us r would be positive or negative the square root of 3v over pi h. Now you would like to say, well, we're done, but that gives us the square root of 3v over the square root of pi h, right? Well, some old dude long time ago, okay, before calculators, yeah, there's really no reason for this, but it is what it is. Some old dude long time ago decided it was not pretty to have square roots or roots on the bottom of a fraction. So we have to get rid of it. In order to do that, then we multiply by the square root of pi over h over pi over h. That's multiplying by 1. Okay? And so that gives us on the top the square root of 3 pi VH. Now, why did I move the pi over? Just because it's a number like the 3. It's just prettier to write it that way again. And on the bottom we have pi h. Okay? And that's our solution. I know it looks like a big mess, but that was the idea. Okay, and part B. For this one, we're supposed to solve for t. Guess what? We got this square here. We're probably going to have a trinomial. So we have mt squared plus nt. Subtract the z from both sides equals 0. We've got to solve this thing. We've either got to factor, complete the square, or use the quadratic formula. The easiest way to do this, and maybe the only way, would be to use the quadratic formula because t is in our x spot. Yes, this does look like the same thing as ax, or t, squared plus bx t plus c. Okay? So we're solving for t by using the quadratic formula. So here we go. Negative b. What's b? N. Here we'll just write this down. What's a? That's m. B is n. And c is negative z. Okay. So t is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's pretty close to it. We just need to simplify with that negative z there. So we've got negative n plus or minus the square root of n squared minus or plus 4mz. Because we had a negative 4 times a negative z gives us a positive. Over 2m. And believe it or not, that is as good as it gets. So we have solved for t, and that concludes